So we've called this project the eGalleon project. So I'm Lionel, I'm technical director at AnotherPeak here in France, in the French Alps, in the beautiful French Alps, in charge of what this project is, that is around electromobility. So the idea is that we have connected IoT devices, pretty significantly big IoT devices that are as big as galleons. And the idea is to leverage on the EdgeLake functionalities to prepare for the future. That's really the intention, and we have some immediate goals on this project with some really long-term objectives in mind, and this is what the customer has asked us to do. So the idea is to go from a pretty cheap design, very simple, and by incremental move into something that is really future-proof. So the context, we're in this e-mobility. The idea that you see a boat on the picture. The company, it's made of 3 companies, but they are part of the same holding. They are managing fleets of boats, cruising boats, in 3 lakes here in the French Alps. They have something like 13 boats, goes from 12 to 15 depending on the season, that just got upgraded to electrical power. So they are not hybrid, they are really electrical power. They went from diesel to full electric with batteries. And the main challenge is of course, to ensure the best battery lifetime. This is the batteries become an asset. And the second part is to assist pilots in the autonomy management. The way you manage boats going from diesel or petrol engines to electrical engine is a totally change of mind, and the way they will manage the asset across the day, across the season is going to be totally different. So for that, we have decided to build what we call the data consumption case with some central data access. This is something that is required for creating a dashboarding to exchange data with different partners, with different actors that require this aspect. So we work in the batch mode so that we can operate at night, do some data science, and I will talk about that. And the having access to some potential data for support, for example, in order to better prepare, for example, if there is a temperature increase in the batteries or some maintenance issue that need to occur pretty much immediately. And to help the pilot, there is also a way to invert the process. So we acquire data, but we also can push data towards the pilot. And this is something we will talk about. So like I said, we are here in the French Alps, so 3 lakes, one that is called the Lake d'Aix, Annecy, that is called the French Venice, and the Lac Léman, that is north of Geneva, going to between France and Switzerland. And you have some beautiful pictures of the boats here. So the boats are significantly big boats, like the Libellule, the one on the bottom left. That is like 400 tons boat, 60 meters long, 500 people. You can have dinner or lunch on it for something like 250 guests. It has significant power on it, 4 motors of about 200 horsepower each, and something like 700 kilowatts of battery, which is pretty significant in terms of weight. And in terms of cost, the cost of equipping this boat was really significant. And this is why we say that now the batteries become an asset, a financial asset, that we need to maintain and make sure that they will run for a significant amount of time. The other boats are majority made of boats that are in between 100 to 150 people, 2 motors for redundancy, and because they were done like this, something like 200 kilowatt batteries each, fully electric mode, fully redundant, really secure, but still a different way of managing the systems. So for this change of paradigm, there was a new gen of data platform that was needed at the time. So we needed some analytics of the state of charge, the SOC, and the SOH, the state of health. So batteries are, there is chemistry and power and so on, but the way you really manage them and maintain them is by monitoring these numbers. They are not number of quantity of volts, amperes, or power. It's a matter of how long they will last. This is what you see on your phone, which is a state of charge, a certain percentage. And the state of health is also something that is degrading along the years as you use them, better or worse. And the idea is to use data acquisition in order to enhance or at least maintain in the best state as we can their state of health. And for that, we do data acquisition, but we also prepare for AI models. And for this, there are the standard process that is data science. So you need to discover, learn what the data are made of, and then you can apply AI models on them. So the old approach was to say, we're going to retrieve all the data. So this is the IoT. You transfer all the data across any IoT network to a central place where you would process, like the Azure IoT or the one that you know from famous companies. You generally put intelligence application on top of them. You need to make sure that the network is reliable. It creates a lot of hurdle that we didn't want to go. A lake in the middle of the mountains is not a secure place for data transmission. So the idea is to go to a new approach that say, let's refine, let's transfer, and let's keep data local. Makes the queries from the central system whenever we need. So we don't need all the data all the time. We just need to know, for example, when an engine is reaching a certain threshold, 1,000 hours of runtime. We don't need to know each and every hour that has passed. We just need to know when the 1,000 hour threshold is reached. So we process locally and then push from this local information to a central system the data when we need. So the boat is essentially made of two things: a BMS, a battery management system, from which we retrieve data on a regular basis locally. We keep them locally with what we call the boat edge. We also use other sensors like temperature from the water, we look at the weather, we look at how many people are located on the boat. And eventually we push data directly to the control dashboard for the pilot to help him, assist him on the cruises. So what drove us to pick EdgeLake? You understood that the fact that we could run on the edge, acquire data, do some local processing. So this is the what we want to have as a smart battery management, to do more local processing, ingest more IoT data, like the lake production. We think that the boat is not only to transport people, but it can also be involved in the atmosphere, in the ecosystem management. It opens access to suppliers, meaning that for the boats that need a significantly high level of management, we can publish data. So we can help publish data, only the relevant data, and I will explain how we do this, to selective partners that they will be the one that are managing the batteries, the one managing the engines, the one managing the boat as a ship, without having to upgrade the central platform. So we really wanted to maintain each and every boat as a standalone device, being able to behave on its own. Of course, being part of a fleet, but that was really the idea. So the boat, each and every boat becomes like a source of data for the consumers, both internally for our own usage, and I will explain what usage we do with this, but also from external actors. We didn't want to go into some complex network design or something that was really gigantic. So we say every boat is connected using 4G. It can or cannot communicate depending on the connections. This is because we use local data acquisition and processing. We are not really in a rush in order to transfer the data and in order to process it. So if there is something that is urgent, the decision will be made locally on the boat, so that, for example, the captain will be alerted that there is something that is wrong on one of the engine. This is all happening locally thanks to the edge capacities. So it provides simplicity on the network design, but also some savings in terms of data to be transferred. We don't really rely on the network. We use it, but we are not dependent on the network status. And we don't risk any data loss because everything is retrieved and stored locally and used only when needed. It doesn't mean that we cannot transfer everything, but we do it on purpose and whenever we need it. The third aspect is we can add any new edge in a very transparent manner. So today there are 12 boats, 13 boats in the fleet. We know that the company is going to expand, add more fleets in the future. One boat, one edge, that will be a new component. And the way we acquire data that is not dependent on the vendor. SOC, SOH are all very standard measure that we retrieve. And the idea is that we are made of multiple fleets. It's 3 different companies, but still we work in an ecosystem that is representing a single infrastructure. If tomorrow we work with a maintenance company and we say, we want you to maintain our 13 engines of all the boats, this is part of the solution that we have. So EdgeLake is really a game changer. It's a change of paradigm from the last 10 years, which was everything needs to be centralized, and going to the edge was significantly difficult. We are back to the concept of client-server distributed way of having access to data in a reliable manner. And we call this infrastructure for data producers and consumers. The idea is that the infrastructure is here to serve the need of, we are part of the consumers. We are the producers, of course. We could be also consuming data from other producers. I would take the example of every boat as a diesel generator, as an energy supplier that will eventually complement whenever the batteries could lack some resources, whenever there is a failure. So it's a mix of security regulation and comfort for the pilot to be there, but still they become a producer of data, and we are in this aspect the consumer. There was a challenge to consider, so we wanted to go step by step. We start simple, very simple architecture. EdgeLake was really helpful on that aspect, because EdgeLake is, once we know which data to gather, we can just forget it, because EdgeLake is going to be to store it, make it available, whether it's going to be local or remotely. When I say remote, from inland and from any consumer that will be part of it. And we foresee the blockchain will be key for the project. I will talk later on about it. The idea to use blockchain is to say, you are a consumer, you may not be able, or you should not see what everybody can see. So if you are a specialist on motor maintenance, you don't have to see the batteries. And the blockchain is here to maintain this level of data access separation. Back to the project, we had 2 primary goals. The first one was to have a real understanding of this famous state of charge and state of health, to take the right decision for operations, so the day-to-day activity. And the second, which is more long-term, which is for maintenance. So SOC and SOH are the key factors. By the way, SOC and SOH are pretty much linked together, but essentially what they represent is how in a good shape each and every battery, so we talk about battery packs, how they are. For immediate operation, so the captain is going on the boat, going for cruise, the captain needs to know, and by the way, the commercial people also, they need to know how full the battery is, and when it's leaving and when it's coming back, and they want to know this on a very regular manner and very reliable. The SOH is more for the maintenance, which is more the long-term aspect, where the SOH is something that is not varying a lot along months, but still this is the factor that is used to say the battery is in good or bad health, in terms of how it's going to be able to assist in the propulsion of the boats. And what we wanted to achieve was to be able to select the most impacting strategies, meaning whether you drive at a certain speed, if you transport a certain number of people, so the load on the boat, depending on the weather conditions, depending on how long the cruises are, and so on and so forth, it will have an impact on how the batteries are going to be used, consumed. So you consume battery as you move, but also on the way they will have to be charged. So the boats, because they are going on cruise, so they are making rounds across the lakes. There are times where you can charge them. Is it good to charge them in the morning, in the afternoon, in between cruises? Should you do a one-time charge, a significant one-time charge, or is it better to do multiple small charges or across the night? These are all information that we need to get data for in order to analyze what will be their impact. The second aspect of our goals was to determine the best auxiliary energy. I said that there is a diesel generator on the boat. The whole project relies on the boats were electrified to become, CO2 free. This because there is a diesel generator. This is not completely true. This is what we call hybrid. The first thing, we need to know how much of the generator is used. So for that, we need data. And the second step is how can we optimize the use of the boats, of the fleets, of the batteries themselves in order to minimize how much of this diesel generator is going to be used. But we can think otherwise. We can say, okay, the generator is one aspect of this auxiliary energy. It could be solar panels, it could be turbines, it could be any other things, maybe increase the number of batteries. Maybe by adding just one more, it will eliminate completely the need to get to the generator. So this will minimize the consumption, of course, the pollution, while it will maximize the battery lifespan. So this has a direct impact on the day-to-day activity as well as the long-term activity and the asset. Again, the boat is really an asset and the batteries are part of this insignificant asset. Like I said, the setup that we did is very simple. The boat, each boat has an edge, so a small device based, an atom-based, really, really simple, local SSD. We do run some script on them. They will connect to the industrial systems. They will be different depending on the vendor, on the system that has been equipped on the boat. There will be different interfaces that we retrieve. So it could be some very industrial buses. It could be some IT-like systems. We talk with data loggers mainly. So we store this information locally. So we retrieve locally. We store on the EdgeLake operator, and when needed, the needs is coming from multiple angles. There is a need to create a dashboard. There is a need to create some alerts to the captain. There is a need to maintain what we call the logbook. Every boat in the world has it's a regulatory that when any boat is leaving an harbor and coming back and has a route, it needs to log what it does, how many people, what are the loads on the boats, etc. So these are the data that are getting sent to the EdgeLake master, thanks to some scripts that are run, that are querying the data. And based on that, we create either the dashboard that I will show later on, or we push some reports. For example, some entity that I mentioned here, like the DDT or VNF, they are regulatory observatory companies, private or public, most of them are public, that really focus on, for example, CO2, that they want to have reports made every month saying, we've saved this month, we've saved this amount of tons of CO2 because we are now running electric. So one example of the report that we initially created, this is 1 year of run across a boat. This boat is called Helios. So the yellow and green are starboard and port side. So we monitor the SOC, like I said, so every line, this is a very long period, so it's not very detailed, but we have access, of course, to the much more detailed information, where you have really the evolution, and we see that the charging is complete 100%, and depending on the day, on how many cruises there had to be, what kind of cruise had to happen, we can see how low it goes, and we can also see how the generator was involved and how it was impacting. I will show you later on what how it was used. So at the beginning, we saw, okay, every few minutes was sufficient to build the graphs, to see how the batteries were behaving, if it was sufficient across the day and so on, and to make data science work on it. We monitor temperature, the power, and the beauty of it is that we only had to retrieve the data when we needed it. There was no need to transfer all the time. An example, like I said, some regulatory system required the boats to be followed all the time, and this is something that is on top of it. So this is part of the consumer that we are providing data with, which are the geolocalization of the boats. And like this, we are able to create the route of the cruise that has been happening, so we know exactly where the boat is. It has also an aspect on the way data science that we do on the data in order to determine how good the SOC and the SOH are going. Is that because we know exactly where the boat is, which direction, and the weather, the weather aspect, we're able also to compensate what we observe, which is very important for our objective, that is to optimize the lifespan of the batteries. Something interesting that we did, and this is just for the fun. So depending on how you look at the data, it can show something very sometimes amusing, but the idea is, and this is why you have left and right, when you go on the lake, there is of course wind that is going across the lake. So if you go, if the wind is blowing from the north, and you go north, you are going against the wind, so you will consume more battery power when you're going to than when you're going back. And this is exactly what we wanted to see, and this is what you have on the bottom right. You have the distribution of energy spent on the way to, and on the right is the way back, and we can see that the trend is more to consume more on the way to than on the way back, which confirmed that there was significantly more energy spent going against the wind than going with the wind. This is something that we've been playing to. But the interesting part is this. Thanks to the data that was acquired by EdgeLake, again, it was here on a low rate. I call this low rate or regular rate. We have created the update. So the picture that you have here is 1 day of operation. Every rectangle, color rectangle is a cruise. Okay, so here there are 2 days. The one on the left is the one from a certain day, September 20th, and the other one is from August. So August is really high, the peak season, and September is the low season. The color are the same cruises. So this 2 days, but still the same cruises. So 4 cruises. You can see that the one that is on the right, the cruises are really evenly spread across the day. There are some small charging periods, one that is in the middle of between the second and the third, and one that is between the third and the fourth. And we are looking at how quick the charge was going. We were able to see also, because there was a generator that was going on, so we could see the impact of how the generator was helping the batteries sustain a certain SOC. And what we discovered by looking at the second one, where this is the one on the left, where you have the 2 cruises really close together, there is the break that is the white in between the 2x2 cruises. That is, there is a strong charging period that is for lunchtime. And by having this strong charging period, we discovered that there was no need to activate the generator. So having this showed that having the same spending on energy, but having a different agenda in the day, saved energy and didn't require to activate the generator, which was at the end of the day what we wanted to do. So with direct observations, we could record how fast the batteries get drained, how the onboard generator helps, but also how the effective was the top-up charging. We call this biberonnage in French. That is like you do very small add up to the top up to the SOC, to the charge of the batteries. And it was not until we saw it, it is never evident to be able to be totally convinced that this will work. And this was our objective. Now there were things that we wanted to go a little bit deeper. And this is where we activated what we call the high frequency data acquisition. So instead of we were going like 5 minutes acquisition, we went to 1 second acquisition. In order to do this, you cannot transport everything across the network. So this is exactly where the EdgeLake local, we call this, it is called aggregation. So by this, we say, we use the same script, and instead of having the script running every few minutes, we say run every second. So every second it does retrieve the same data, but instead of storing it directly, it will send it to a function that is called aggregation. And instead of doing what we call the 1 second retrieval, 1 second storage, it goes into the 1 second retrieval, aggregate, and then store. And the storage will do what we are interested in, which is to capture only the maximum value. So in reality, it has the mean, the max, the average number of occurrences. We were interested in the maximum. And by doing this, we discovered something that was key to our analysis on the impact on the battery. So the graph that you have on the right, on the left, is the graph, it's a few hours among the day, of the activity on the boat. So you see the SOC, the boat is going like 10 a.m. in the morning, going out few navigation. And on the one that is called current is the amount of current that is requested from the engine. So the current while the boat is driving is significantly flat. We know for a fact that the captain, when the captain exits from a certain harbor, when he leaves the harbor, it puts some significant stress on the boat, which means on the batteries. And without the high frequency acquisition, we couldn't see it. It was averaged. Now that we have the high frequency acquisition, this is the one that you have on the right. This is the after. We can see here that there is a peak of current that is requested from the batteries that is going down to like 70 amps, which is significant on the batteries. And this has an impact on the degradation of the batteries that, if you remember, they are asset for the company. And for this, we didn't have to transfer all the data. We had to make the aggregation, like I said, query the specific data, so get the maximum. We are looking into the maximum for this value. For some other aspect, for example, for the SOH, we are looking for the minimal value. So this is what aggregation function provides to us. And by doing this, it really gets to our profound needs, that is to maximize the management of the batteries. Does it mean that we are going to implement some kind of limitation on the current that is requested from the batteries? This is not yet decided. This is up to the company to do that. But now we can see it. Before that, it was absolutely impossible. Before EdgeLake with the aggregation function, it was absolutely impossible to do it. Other system that we have implemented is, like I said, we can do some local management on the of data and local processing and eventually decision on the boat itself. So we have implemented some rules for data gathering on the edge, and we can also use the edge not to take decisions. This is not the way the edge is not going to say, I'm going to stop the boat, I'm going to prevent anyone doing something. But because there is a captain and the captain is king on the boat, we provide local information to, so the company that is providing this application is called Button. It's an application made by this company. The captain has it because they need to remember they need to fulfill the logbook. So they need to say how many people on the boat, what is going to be the route when they leave, etc., etc. What we have added is the way to notify the captain using this application that he has always with him on emergency. The one that I show here is to say it's a recommendation saying réduire la vitesse is slow down by 2 knots. And why do we do this? We do this because we have implemented a logic on the boat. We know which cruise is going to happen, so which route the boat is supposed to follow, how long it should take. And here, the system has detected that the boat was going too fast, not because we think it's going to consume too much, but because we know it should leave at 11. It should go to the endpoint because it's a cruise. It should reach the destination at 12 at noon. And by going that speed, it's going to be too early. We don't need to spend that energy. We need to save on the energy to maintain the capacity and to maintain the health of the batteries. So like this, we don't tell the captain slow down. You should slow down. The captain still remain master on his boat, but still you are like 3 minutes ahead of schedule. Please reduce your speed by 2 knots. We can share data, for example, for maintenance. We log information from personnel on the boat, something that was missing. Let's say that a personnel could see that there was I don't know, like a French wine in the fridge. This is something that can be pushed. We don't do it using EdgeLake, but this is the kind of information that can be pushed back into the data store and can be used. So this is kind of add-on to the system that we implement. We do fleet management for cruises planification. Sometimes it's not necessary to take a 150 people boat when there are only 30 people to be carried. So this is where the system that is managing the fleet as a complete asset is going to be able to say, okay, you should take this smaller boat that will save on energy again, and that will save also on the capacity that has been stored on the batteries of a certain boat. Last but not least, the boat, thanks to the edge function, the boat becomes a source of data for partners. By doing this, we started to spread the word. And so we are participating into a project, a national project that is what we call open data. The subject of the project is to say, we, as this company working with cruise boats on the lakes, maybe we have some synergies with some good transport boats on the rivers. Maybe with the one on the rivers in Paris that are also transporting some tourists. But eventually we can even go further. Like we transport people, but why not go and talk with the truck managing companies and say, you are thinking about going to electric trucks. We know how a boat is behaving. Maybe we have some similarities and we need to exchange. So we communicate directly with partners to feed them with our data for maintenance purpose, like the logbook, like I said. So we are helping maintain this logbook, like the routes, the propulsion element that need to be recorded for maintenance. But we can also aggregate and publish these information to external partners with reports, with regular and permanent feedback to the systems. And at the end of the day, and this is one of the objectives, and building a community. And this is what we expect, for example, with this company that is called Boton that we are working with very closely, is that if they become an EdgeLake actor and they bring their own EdgeLake entity, we could expand, or we could extend our network to their network and then make some data exchange on the technical level that will simplify and automate the data transfer that today requires some specific agreements, some specific network transformation in order to be able to exchange the data. With EdgeLake, we can very simply create the network and control the different data and the data access that is going to be done with all the different actors, whether they are partners, vendors, with some proper hierarchy, data access separation per entities and privileges. And so this is for us the future, but it's a strong advantage that we see using EdgeLake. And with this was the end of this beautiful story. And I love being beyond the boats, as you guess. I think we have few minutes for questions. If there are any,
Thanks.
you are welcome.
Thanks. Yeah, thanks a lot, Lionel. Great talk. I actually have two questions. The first one is on pull versus push. So I think correct me if I'm wrong. So most of the data that is being queried is now done using pull. From a query point of view. You issue a query to the boats, and then you get back the information that you
That's,
want. Have you have you looked at push, meaning there is the rule engine that is on every EdgeLake instance, and you could configure it to look at things and then push when something is happening, or
yeah,
you could have a push every X time just as a status and have on a query node you. So I was wondering if you were looking at it or using it.
yes. So yeah, you're absolutely right. We did the mostly everything is in pull mode. We are thinking about going to push mode when something is really urgent, like batteries are very dangerous systems. So this is something that we are looking into, like when the system is going to detect that there is something wrong happening. An example would be that the temperature is going across a certain threshold to push information. So we don't know which format is going to be the information. It could be SMS, for example, to notify the relevant people. That will be the captain, but it could be also someone that will be inland that say, okay, there is a significant alert around the battery's temperature, for example, and some urgent decision should be made.
Yeah, great. Yeah, so would be curious to see how you would be leveraging it. And the second question that I have is about the network layer. So you had a diagram where you're showing some of the data goes through the 4G. Yeah, this one.
Yeah.
And then it goes into the internet. And I was wondering how you configured it and what's being used here. Are you using a telco service here, or if you could talk about a little bit about the
Yeah,
network
sure.
setup?
So in terms of network, every boat already had some Wi-Fi on board. So we connected the edge. We connected the edge to this onboard Wi-Fi, and the Wi-Fi is as a SIM card that connects the boat to 4G network. So to public 4G network. It's not private anything. It's public 4G. It's like a €10 per month SIM card with limited data. We could expand a bit, but because we are using EdgeLake, we don't need we don't consume a lot of data. So really onboard Wi-Fi that was used for other purpose. It was like onboard cameras for video surveillance. And we leverage on this Wi-Fi to connect the edge 4G that was already there. And this is why we connect to internet. The reality underneath is that we have a VPN agent that is running on each and every edge. So it simplifies and kind of secure the data transfer from the operator to the master node whenever we need it. So it's a
Right.
solution that was really simple, that was partially in place. The Wi-Fi and 4G was already in place. So we leverage that and we say, okay, we need to secure it. And the customer decided to implement a VPN technology, software-based, and that we leverage also to create a local switching network, switching domain for the operator to the master communication.
I see. And on the boats, do you have a PLC? How do you pull the data from the sensors there?
Yeah, so that depends on the vendor. So typically today for the electrical chain, that's I call this they're already part of the IT domain. So they use Modbus or they use CAN bus that are kind of industrial already binary buses. So they're already talking in binary mode. What we use are called data loggers. So the reality is that the edge is not talking directly to the battery, to the BMS, to the battery management system. It talks to a data logger that is a very small device that is able to talk to the industrial layer, and that makes a connection to, like any connection we know that talks HTTP with XML, JSON objects. So this is the majority of the case because these systems already kind of part of the computer world. For other devices like generator, the generator is more ancient, old industrial systems. Still, they have buses. The one that we use is called Modbus, that are already prepared for connections to the software layer, to an IT world. So depending on the entity that we talk with, they are more or less prepared. The reality is we use typically gateways that will allow us to make queries to these entities, and they will make the conversion from our way of seeing this world to their world.
Yeah, great, thanks. So, okay, so Lionel, thank you so much for the presentation. It was a
You're very
great
welcome.
presentation.
It was a pleasure.